In this lesson, we've been answering the question, how are the interior and exterior angles of a triangle related? And we've studied special angle relationships formed when two parallel lines are cut by a transversal. We're going to use these relationships to prove special relationships about the interior angles of a triangle. Recall, interior angles are angles that are formed inside of a figure by adjacent sides of a polygon. Consider the interior angles of any triangle. How can we go ahead and actually prove that the sum of the measures of the angles in the triangle is 180 degrees? Well, actually, we use Euclidean geometry. We start by sketching two parallel lines. One line is actually an extension of the side of a triangle, and we sketch through a vertex another parallel line. We cut those parallel lines with a transversal, and we recognize and remember that alternate interior angles are congruent. And we use this information to help us prove that the sum of the interior angles of a triangle are 180 degrees. We can now formally state the theorem we just proved, and we can use it to find the value of x. The triangle angle sum theorem states that the sum of the measures of the three angles of a triangle is 180 degrees. So what this basic theorem says to us is that the theorem states that the sum of the measures of the interior angles, and that would be angle EDF, angle DFE, and angle FED, the sum of the measures of these angles will equal 180 degrees. So that means we can really just simply sum up the three expressions and set these sum equal to 180. So we have 3x minus 1 plus 67 minus x plus 5x minus 40, and that's equal to 180. Well, combining like terms, what does that give us? 3x minus x is 2x plus 5x is 7x. And negative 1 plus 67 is 66 minus 40 is 26. 7x plus 26 is 180. Using algebraic properties, we can then write 7x is equal to 154. And if I divide both sides of the equation by 7, I find x to be 22. Now, once I know x is 22, what I can do is I can find the measure of angle E, because that would be 67 minus 22, which is 45. I can find the measure of angle D, because I know 3 times 22 minus 1 gives us 66 minus 1, which is 65. And lastly, because I know that the measure of angle F is given by 5x minus 40, I can find the measure of angle X by taking 5 times 22 minus 40, which is 110 minus 40, and this gives us 70. And we know the answer is correct. Why? Well, when you add up the angle sum, or when we add up the angle measures, they sum to 180 degrees. 45 plus 65 plus 70, 180. The third angle theorem. This says if two angles of one triangle are congruent to two angles of another triangle, then the third angles of the triangles are also congruent. Now this should make sense. It really follows if you think about it, because if you have two corresponding angles of the same measure, so we have a pair of corresponding angles in each triangle, and if we know that the interior angles of a triangle sum to 180 degrees, substitution will enable us to say that these third angles must also be congruent. Well, let's prove this theorem with an interactive. We have triangles ABC and DEF, and we're given that angle A is congruent to angle D, while angle B is congruent to angle E. And what we need to show is that angle C is congruent to angle F. All right, so our first step is to state the given. And our given is that angle A is congruent to angle D and angle B is congruent to angle E. And if you do have congruent angles, you know the measures of these angles will be the same. So our definition of congruent angles says the measures of A and D will be equal, and the measures of B and E will be equal. Now, what else do we know? Well, we know that the sum of the angles, sum of the interior angles in a triangle is 180. So, by the triangle angle sum theorem, we can take the measure of angle A plus the measure of angle B plus the measure of angle C and set it equal to 180. And we can do the same for the second triangle. Take the measure of angle D as well as E as well as F, sum them up and get 180. Since we have two equations, each set equal to 180, we can go ahead and set the two sums that are equal to 180 equal to each other. And once we have those sums set equal to each other, look very carefully at step 2. Because while step 2 says the measure of angle A is equal to the measure of angle D, we can interpret this to mean we could replace the measure of angle A with the measure of angle D. So if I take a look at step 5, on the left side, I will replace the measure of angle A with the measure of angle D. Also, I will replace the measure of angle B with the measure of angle E, again because of what I see in the second step. So again, on step 5 on the left side, I'll replace the measure of angle B with the measure of angle E. And this gives me, using substitution, that the measure of angle D plus the measure of angle E plus the measure of angle C is equal to the measure of angle D plus the measure of angle E plus the measure of angle F. That's a lot to say. So now I'm going to see if I can solve this or equation so that I can go ahead and isolate on the measure of angle C and the measures of angles F. I will subtract from both sides of the equation the measure of angle D and the measure of angle E. And this gives me that the measure of angle C is equal to the measure of angle F, which tells me that angle C is congruent to angle F by the definition of congruency. This tells me that the third angles in the triangle will be congruent. You've done a really good job answering the question, how are the interior and exterior angles of a triangle related? Now we've explored the sum of the interior angle measures of a triangle. Now we're going to define and explore the relationship between exterior and interior angles of a triangle.
Here's something interesting about triangles. We can find more angles related to a triangle than just the usual 3. Triangles consist of 3 interior angles, as well as angles known as exterior angles. Let's look at this triangle as an example. The interior angles are angle BAC, angle ABC, and angle BCA. All right, to find the exterior angles, we'll have to extend the sides of our triangle. Let's extend this side to a point Z, this side to a point X, and this side in the other direction to a point Y. Now we can see our exterior angles. We've got ZAB, XBC, and BCY. But wait, we kind of just picked how to extend those sides. We could have picked differently. We could have extended different sides in different directions. This side could extend to a point Z, this side to a point X, and the same side in the opposite direction to a point Y. Now our exterior angles are ZAC, ABX, and ACY. But just because we can pick how to extend, that doesn't mean we can draw any extra line segments. Exterior angles are created by extending only one side of the triangle and should be supplementary to the interior angle. That means the measures of an exterior angle and its corresponding interior angle should add up to 180 degrees. For example, if we extend this triangle's sides like this, we can see these angles are supplementary. The measure of angle BAC plus the measure of angle CAT equals 180 degrees. If we're not careful how we extend the sides, we might not get any exterior angles, like here. These two angles are not supplementary. We get to choose how to extend sides for exterior angles, just as long as we still end up with exterior angles.
exterior angles of a triangle are more than just supplementary to their adjacent interior angle. The exterior angles theorem tells us that the measure of each exterior angle of a triangle equals the sum of the measures of the remote interior angles. Now, the remote interior angles are each of the two non-adjacent interior angles that correspond to each exterior angle of a triangle. In other words, in this particular diagram, the exterior angle is angle ABD, while the two remote interior angles would be angle BDC and angle DCB. Well, let's go ahead and walk through an informal proof of this. And the first thing I'm going to do is just label angles for simplicity 1, 2, 3, and 4. Now we know that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And we know this because an exterior angle is supplementary to its adjacent interior angle. And we also know that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. And this is because they are all interior angles of a triangle. So we can substitute. And if we do, we have the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. And using the algebraic property of subtraction, we can subtract the measure of angle 2 from each side of this equality. And what does this leave us? Well, this leaves us with the measure of angle 1 equaling the measure of angle 3 plus the measure of angle 4, which is exactly what we were looking for, which was the measure of the exterior angles equal to the sum of the measures of the remote interior angles. Let's look at an application of this. And in the application, what we want to do is find the measure of angle XFE. And we're going to use our exterior angles theorem because we know that our exterior angle is equal to the sum of the measure of the two remote interior angles. So let's write this out. What do we have? Well, we have the measure of angle XFE, the exterior angle, equaling the measure of angle FEG plus the measure of angle FGE. Now, let's substitute in their expressions. So what does this give us? Well, this gives us 3K plus 30 is equal to 95 minus K plus 2K minus 5. And if we combine terms, we end up with 3K plus 30 is equal to 95 minus 5 is 90. Negative K plus 2K is plus K. Well, let's go ahead and solve. Let's subtract the K from both sides of the equation, leaving 2K plus 30. And that's equal to 90. Subtract the 30 from both sides of the equation. That leaves 2K is equal to 60. And we find K is equal to 30. And once we know K is equal to 30, we can find the measure of angle XFE because we know that the measure of angle XFE, well, that would be equal to 3 times 30 plus 30, and that's 120. The exterior angle inequality theorem. This says the measure of an exterior angle of a triangle is greater than the measure of either of the two non-adjacent interior angles. Look at this diagram. Here's our exterior angle. And we know that the measure of angle 1 is going to be equal to the measure of angle 3 plus the measure of angle 4. Well, what does this mean? Well, it should follow that the measure of angle 1 is going to be greater than either the measure of angle 3 or the measure of angle 4? Either one. Because we know the measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 4, the sum of the two remote interior angles. So that means we can write that the measure of angle 1 is going to be greater than the measure of angle 3, and the measure of angle 1 is also going to be greater than the measure of angle 4.